and let me know what you want to go over, because you have a review sheet that's got in your packet, and you have all the delta maths that I've been assigning. You got 12 questions in your packet that cover everything that will be on the quiz. But I wrote down some of the topics here. All right, so I got theta equals S over R, SOHCAHTOA. I tried to go through every question on the quiz and write down the topic. You know, a topic could show up a couple times on the quiz, but I just wanted to let you see all this. And then I can find a question on your review that kind of matches it. But again, you have all the delta maths. All right, if you want extra practice with something, and then these 12 questions, which I don't know is enough for some of you, but at least it's something to practice. I just don't want this period to be go at it, because I don't know where that's going to lead some of you. All right, Jeremy, you had your hand up.
Can we go with coterminal angles?
Okay, yep, coterminal angles. Let's see. Do I have any on here? Determine. Yep, number 7 in your review. And I'll actually make a part C up, because I know something's not on here that should be. All right, find an angle that's positive and an angle that's negative that are coterminal with each angle. So I have 300 degrees right now. 300 degrees, what do I mean by coterminal? An angle that shares the same. So if I have an angle of 300, let's see, something that looks like that here. Name another angle that's positive and negative that looks just like that. So what have we been doing with our degrees anyway? Adding, subtract, 360. Yep. So we could say a positive angle that's coterminal is 660. And I also would subtract. Now, hey, I've seen some of you do this. It's not 360 minus the angle. It's the angle minus 360. So negative 60. All right. So it's just add 360 and subtract 360. Don't put 360 in front.
Unless you're finding a reference.
Well, but I don't even want to get into, because that's not even part of this. This is just coterminal, so I don't even want to talk about the reference angles. Okay, everyone all right? All right, now let me change it, because anything I ask you to do in degrees, I would expect you to do in radians, okay? So I'll let you go part B on your own some other time if you choose. Let me do a part C right now, and we'll do 10 pi over 3. Find a positive and a negative angle that's coterminal with 10 pi over 3. Again, anything I ask in degrees, I'm expecting you to do in radians.
600.
Okay, so you have your choice. Okay, we have choices now, which is great. You can turn this into degrees and do what we did up here. Or instead of adding and subtracting 360, what's the equivalent again in radians for 360? 2 pi. So whatever you're comfortable with. You could add 2 pi, but be careful, unlike denominators, right? And subtract 2 pi until you get a negative answer. Or some of you may feel comfortable, take 10 pi over 3 and convert it into degrees and do what we did up here. But the only draw, let me do this right now just with 10 pi over 3. I'm just going to, how do you want to convert it? Let me ask you guys. You guys are taking the quiz. You remember what pi over 3 was?
45.
Ooh, no. 60 times 10, 600. Or if you don't remember that, what's the conversion? What would I have to multiply it by to get it into? Not pi over 180. 180 over pi. If you don't remember that pi over 3 is 60. Pi's cancel. You would get 600 degrees. Okay? So, all right, you get 600 degrees. All right, now I'm going to add 360, and I get 960. Yeah? But here's the thing. If the question starts in radians, that's not going to be acceptable, 960 degrees. It's going to have to be in radians at the end. So you would have to convert. What would I have to multiply by? Okay, pi over 180. Let me slow down a little bit right now. There's no cross multiplying here. No cross multiplying. What should you leave in your answer if you're giving me radians? The pi should stay in your answer, And then everybody on their calculator should be doing 960 over 180. Which is, I'm not even, whatever that turns out to be, I guess.
16 over 30.
16 over 3. Okay, so 16 pi over 3. And then I'd have to keep subtracting 360 till I give a negative answer, turn it back into radians. So what I'm trying to tell you guys is this, turning it into degrees is a little bit more work, but you may feel more comfortable. Doing it, adding 2 pi and subtracting 2 pi may be a little, it's less work, but you may not feel as comfortable. Have a plan though, have a plan. If the question is given in radians, your answer should be in radians. So there's coterminal. All right, there's coterminal. Add and subtract 360 or 2 pi. Anything else? Let's keep going. Ryan, go ahead.
Theta S over R.
Yeah, we need, definitely. Just going from your pop quiz there. All right, we can do a couple questions using theta equals S over R. Let's go to, I know I got 2 of them on here. Here we go, number 10. Okay, number 10. Anytime tomorrow, look, I see a circle, radius, boom, theta equals S over R. There's no discussion. All right, no discussion. Theta equals S over R. Right off the bat, you got 6. Where am I plugging that in for? Radius R. All right, so 6. A central angle has a measure of 5 radians. Where's the 5 going?
Yeah.
In for theta. And is it okay if I just plug in 5?
5 pi. No,
Why pi?
it's radians.
Okay.
Yeah.
But remember, radians don't, 99% of the time, it will have a pi, but sometimes it won't. So this is just, is this in, here's my question. Is this in radians?
Yes.
Okay, so there's no reason to convert it. 5. If it's in radians, plug it in. If it's not, I got to convert it. So there's 5, and I'm solving for S, my arc length. Cross multiply. Put the 5 over 1 if you'd like. S equals 30. Or the arc length equals 30. Next up, number 11, right underneath it now. Another circle with a radius of 2. But now what's the difference? And this is what we got caught up on the quiz with. Radius of 2. So 2 in for R. But hey, guys, look, this is no good right now. That can't happen tomorrow. Why not? I don't know what else to, I don't know what else to do. Do a cartwheel or something. You cannot use this formula if the angle's in degrees. You cannot plug any degree measure into this formula. Go on. What I do need to do, though, is take 100 and do what? Put it into radians. Put it into, ready? Here we go. Let's slow down now. What do I need to do to 100 to make it into radians? What's the conversion on your formula sheet? Pi over 180. I do not do 100 times 180. I leave pi in my answer and reduce 100 over 180.
5 over 9.
5 pi over 9. Guys, just put a fraction template in your calculator and do 100 over 180. You'll get 5 nines. That is theta. That is theta. Ready? 5 pi over 9. That is theta. And we're solving for S again. All right, I'm not even going to assume that we're comfortable doing this. Cross multiply. Everyone good? 9 times S.
9.
9S.
10 pi.
5 pi times 2. 10 pi. How do I get the s by itself? Divide by 9. And tomorrow, I know there's none here, but there will be rounding directions. Don't leave it like this. You can't have an arc length and rate. It's got to be like in centimeters, inches, feet. So go to your calculators, 10 pi divided by 9, and let's go. I'll make it up, nearest 10.
3.5.
What is it?
3.5.
3.5. That is what I'm looking for here for arc length. Okay, arc length's not in degrees, it's not in radians. So do 10 pi over 9. All right, there we go. There's a couple thetas equals, and again, I'll say it one last time. You cannot use the formula if the angle's in degrees. Don't even plug it in. Convert it. All right, anywhere else? Let's keep going. Connor, what's up?
Can you go over SOHCAHTOA?
Sure, absolutely. Let's see, where am I here? Let's go to number 4. Also remember a ton of SOHCAHTOA on the delta math I assigned yesterday. So we got a waterfall, 3,212 feet tall. Angle of elevation, 35. What's the torus distance from the base of the falls to the nearest 10th? All right, so we know we're dealing with a right triangle because I see angle of elevation there. And I can't help you draw your diagram tomorrow. I can't. I'm sorry. Where am I going to put the 3,212 if the falls is that tall?
Left.
Bottom left, hypotenuse. Left, 3,212. You guys, I know, I don't expect you to. My expectations are not there because I only went over one problem. Anybody remember where angle of elevation was? I showed you yesterday. Bottom right. Yep. Inside the triangle, right? 35 degrees. What's the torus distance from the base of the fall? So what am I looking for? The hypotenuse or the other bottom side? From the base of the falls.
That's the bottom.
Are we look at your diagram? Can you use Pythag? No, you don't have enough information, and you know 35 degrees anyway, so that should signal SOHCAHTOA. All right, let's go from the 35. 3,212. You have opposite, adjacent, hypotenuse. From the 35, which one am I looking at?
Use tangent.
What am I looking at? 3,212. That is the opposite side, so I like to put a little O. I'd recommend it for you as well. And what's the side I'm trying to find? Adjacent, yep. So now I go to, out of the 3, which one do I use if I have opposite and adjacent? Tangent, TOA, good. So TAN, abbreviation from yesterday. Tangent, you guys want to help me out from yesterday? Tangent of my angle. Yep, tangent of the angle equals, now again, it helps you out. What side to put first and what side to put second. So 3,212, opposite over adjacent. We'll put that over 1, and we will cross multiply like we did yesterday. So it looks like I have 3,212 equals tan 35 times x. How do we want to get x by itself? If you're using the same calculator as yesterday, you should be fine. All right, just make sure you're in degree mode. remind you that tomorrow. And read the directions, find the length to the nearest tenth. So what do you guys have?
$4,587.2.
587. I'm believing you, Zach. No? Disputes?
No, that's right.
No, that's fine.
She's got a completely different answer.
Were you here yesterday?
No.
Hit your mode button.
Uh,
Make sure it's in degrees, not radians.
oh, yeah.
And then just hit enter again when you go back to your answer. We okay here? Yep. Anything else you want to talk about before I just let you go and try out problems either in the packet or on Delta Math? Pythagorean theorem? All right, looks like I'm going to have to add in question 13 because I don't think I see any here. Okay, no problem. Okay, there you go. Nice quick one here. If you wanted to use SOHCAHTOA, why is that impossible here?
I don't have one of the
I don't have an angle, right? I never use the 90. Right? I don't have an angle, so I can't use SOHCAHTOA, but I do have all three sides. All right, when I see I have all three sides, that tells me I can use Pythagorean theorem. If a side is blank, can't use Pythagorean theorem. Need all three sides. All right, what's going in for A and B? My two legs, A and B, are x and 25. So x squared plus 25 squared. Again, don't think you're always solving for C. That's not the case. C is the hypotenuse, and I actually know that. So that's why there's a 31 going in there. So here we go. Let's see, 25 squared. So I have x squared plus 625 equals 31 squared, 961. All right, next move. To get x by itself,
625.
move the 625 over, subtract it. X squared,
396.
961 minus 625. And then your final step to get x by itself,
Square root.
take the square root of x and 336.
You don't need to calculate anything to subtract.
And then, well, I am 18.3. What's up, Zach?
Can you go over number 3 in the packet?
Yeah, sure. Well, it's kind of tough because I don't have, I needed to give you guys the actual diagram. Yeah, you can't do it because find the missing sides. I don't even have the triangle there for you, right? That's kind of tough. That's what I was going to do before I let you guys go on your own. So let me do that now. I'll make it a little smaller. There you go. There we go. So now you just have to find the remaining side using Pythag, and then the angles using sine, cosine, and tangent, like we did the inverse buttons from yesterday. And if you want to just, I'm not too sure if I have this on the answer key, so if you just want to write it off to the side here, TS is 10. The missing side is 10. Angle R is 27 degrees. And angle S is 63 degrees. Okay.
That's what the 45, 30, 60, 90.
There's nothing in there that says 30, 60, right? All right, so you ready to go on your own? Again, I can't stress this enough. The answer key is up on Classroom. All right, up on Classroom for you. So please make use of it. You got your pop quizzes, Delta Math, those 12 problems we've been going over. A lot to get ready for. Let me just check. Unit 3, homework answers. Oh, I gotta put it in there. So I gotta put them in there. Huh? Yeah, I know. I see that.
This is a dirty 6090.
What's that?
This is a dirty 6090.
How's it a 36? I don't understand how it's a 30, 60, 90, Jeremy.
Exactly.
It's 27 degrees and 63 degrees.
Oh, I used the wrong formula.
Okay. You guys can work with each other. Please